Hello, welcome. In this video, I will be solving the 2018 Calculus AB free response question number 1, the escalator problem. Let's get started. So here's the problem. People enter a line for an escalator at a rate modeled by the function r given below. Okay, so this is a rate of how fast people are jumping onto this escalator. We're told some additional information. We're told that as the people get on the escalator, they exit the line at a constant rate of 0.7 person per second. Okay, so that's going to come in handy later. We're also told that 20 people are in the line at t equals 0 or the beginning. So all this information is going to come into play. All right, so part A says how many people enter the line for the escalator on the interval 0 to 300. All right, first let's get an idea of what this function looks like. We can do that by simply graphing it. So if you look at this graph over here on the right, this is this function modeled. Now you'll notice that it begins slowly and then it kind of shoots up. That's because the number of people entering the escalator increases over time. Now about 100 or so, it tops at about 2.5 people per second, and then after that it goes back down. And by 300 seconds, there's nobody entering the escalator anymore. So to figure out how many people entered onto this escalator, all we have to do is find the integral. So we do the integral from 0 to 300 of this function, rt, and we get 270. So there must have been 270 people who entered the escalator during this time period. All right, part B. During the time interval 0 to 300, there are always people in line. So how many people are in line at t equals 300, so at the very end? So we know from the problem before, well, from the very beginning, that there are 20 people in line at t equals 0. We also know that people are exiting the line at 0.7 persons per second. So let's figure out how many people exited the line in our time interval 0 to 300. Well, 0.7 persons per second times 300 seconds is equal to 210 people. So here's the situation. We've got 20 people to start, plus 207 people who got on to our escalator, minus 210 people who got off. So 20 people to start, plus 207 people who get in line, minus 210 people who leave. All that is going to give us 80 people left at t equals 300. All right, part C. What about for t greater than 300? So what about after our interval? What is the first time that there are no people in the escalator? All right, so we know that there are 80 people left at time 300. That's from the previous question. We just need to find how many people are leaving. Now keep in mind, there's no more people entering because our function from before has stopped. Now there's only people leaving. So it's just a simple division. 80 people divided by 0.7 persons per second gives us 114 seconds. Now keep in mind that's 114 seconds after t equals 300, the very end. So from the very beginning, that we just add these two numbers, and that gives us 414.285 seconds after the start. All right, last question. For the whole interval, at what time is the number of people in line a minimum? So nearest whole number, find the number of people in this line at that time. Justify your answer. Okay, so keep in mind, at the beginning, people are entering the escalator slowly, but people are leaving the escalator at a constant rate, and that constant rate is 0.7. So there's a short period of time at the beginning when the number of people leaving the line is more than the number of people entering the line. So that's key. We can model this by subtracting our two equations. So we're going to create a new function, f of t, and we're going to do our first function minus the rate people are leaving. Now if we graph this equation, we get the following figure to the right. And you'll notice that from 0 to this point, 33.013, the graph is actually negative, which means we're losing people. After that, it goes positive, and then after that, it hits another point over here. But we're not really interested in that point. We're really just interested in this first one. So if we calculate how many people there are at that time period, 33.013, we can figure out the minimum, because that's going to be the most interesting point. Remember, there are 20 people to start, and if we plug in using the integral 33 into our integral right here, plug it into our function, do all our jazz, and then we subtract that. Well, I put addition here because this whole expression is going to turn out to be negative. 20 minus this expression is going to give us 3.8, so that's our key right there. At this time period, 33 seconds, there's only 3.8 people, which is about 4 people in the line. Alright, that's all for this video. Thanks for watching, and stay tuned for more.